So we all know this. I'm not going to stress the point. AI is here. It's now. As consumers, we experience AI in our daily lives far more than we do as federal systems integrators or as government customers. That's changing. We're going to see the same explosive growth in federal systems and missions that we've just experienced over the last decade as consumers. So if you came here today via car, you may have used, anyone use a self-driving Lyft? No. Okay, so we'll get to that in a few. Self-driving Lyft car? Yeah. Yeah, right. Yeah, but Lyft, if you use Lyft to get here, the algorithm that scheduled your driver was AI-based. If you drove here in a standard Accord hybrid, you had driver assistance that was AI-based. And if you set your route using Waze, it probably directed you around traffic jams using AI. So you can see from image recognition through robotics, AI is all around us. And I do want a Boston Robotics dog. I think my dog takes too much care. I think plugging in a battery would be best. Recharging a battery is easier than feeding my dogs. So how are we in this golden era of AI? We've had AI for a long time. As Brian, known him for decades. And I've been doing AI since college. It's been a long time. And I had to hide that fact on my resume for many years. And now we're back into a golden age. It's driven by what? 2011, 2012, the discovery or the publication of deep learning algorithms using stacked hierarchical or stacked neural networks, which destroyed all the performance statistics, performance accuracy in the image recognition contest, DeepNet, and that created the revolution. We're there now, but the problem with GPUs, while they're inexpensive, take a lot of them, right? CPUs couldn't run learning algorithms, GPUs can. So using GPUs, we've reached this realm of increasing capability. We've broken, Moore's law ended for us with CPUs. Now we're back on track with Moore's law. We can keep increasing compute power. And with deep learning algorithms using stacked hierarchical neural networks, we are able to solve more problems across a great realm of capabilities, including prediction and forecast, classification, finding anomalies, and recommending action, which is really the whole point of AI. Predicting the future, as Cassandra might do, but not have an action or predict an action or something to take would be a curse, right? So being able to give somebody a recommended action is really the whole reason for AI, or one of the whole reasons for AI. So what are the federal missions that we're seeing that are going to be enhanced? They're here today. There's going to be more tomorrow. We can detect fraud, waste, and abuse. We've been using AI to do this in income tax, in federal income tax returns, and Medicare payments, Medicaid payments. We can detect, reduce, remove fraud, waste, and abuse using AI. We can predict and improve healthcare outcomes, stop readmissions to hospitals. So people who aren't perhaps not treated as well as they could be, we could recognize and suggest actions to take so they're not readmitted to a hospital. We can do preventive maintenance. You heard about the National Mission Initiative from Dana Deasy a few minutes ago on preventive maintenance on the helicopters, right? So preventive maintenance across a broad spectrum of hardware and software is going to fall to AI. Automation of data, information, intelligence. You'll hear from Dr. Nat Fuller later today. He'll talk about how his team is ingesting a huge data storm for intelligence purposes and finding meaning and taking action with that. Video recognition. Our cloud service partners and providers are offering services that make it easy for us to process images and match images. We can match and verify biometrics. We can automate call centers. You'll hear from Dan Turchin later today. He'll talk about Astound and how his call center is AI-driven, reducing the cost but improving the accuracy and the customer satisfaction, which is really one of the most important measures of an AI solution. And then at the end of the day, you'll hear Dell talk about its AI and IoT and analytics at the edge. How do we deploy AI to the edge to take action where the event is occurring? So AI together today is optimizing, it's automating, and it's innovating across the federal mission. Soon we'll be able to put that first slide up for federal missions, and you'll see all the cool stuff we're doing in the federal workplace. In 2018, there was a lot of just hand-wringing around the fact that the US government did not have a federal AI strategy. And so in 2018 and 19, a whole host of strategies came out. We heard about AIM from the Intel community. We heard about the DoD strategy. NIH came out with a strategy, and the White House came out with an executive order, all addressing what we need to do as a nation to catch up or to keep our lead, is how the White House stated it. How do we stay ahead of the Chinese and the Russians for national security, but also for our own economy and helping us to grow? I extracted these core themes from those 4 strategies, and I really wanted to focus on building the workforce for the rest of our talk here today, for my talk. Each of these 4 strategies, the DoD, the the Director of National Intelligence, the NIH, and the White House executive order, really call out. Yeah, turn it down just a little and I'll shout, because we're getting a lot of feedback. Okay, good, thank you, appreciate that. So each of these strategic plans calls out a big problem, workforce. We need to devote our time to building an AI workforce and also encouraging our workforce to be able to work with AI, sort of 2 sides of the same coin. I'll let you look these up later, but basically one of the core problems we're facing is a shortage in AI workers, data scientists. If you look at the graphic on the right, this is the workforce demand. The top line is green. If you look at the yellow line, it's hard to see in this room. The yellow line is supply. If you look closely at the yellow line, you'll see the supply of AI talent, data science talent, is flat. It's plateaued. So we're going to have more jobs than we have data scientists. So there has to be a better way, a different way than just building and hiring them, right? We got to think it through. So this problem, this divergence, is going to continue to grow. So how do we build the AI workforce? We have a series of strategies. Well, first of all, we want to recognize on the right. I'm going to recognize the fact that, what did I tell you a few minutes ago? ImageNet, deep learning, invented in 2012. So how many people have a decade of deep learning experience in the world, right? So if you write a job description looking for a senior AI developer with 10 years of deep learning experience, this is how many people you're going to find. So what you need to do is think through what's happened. Data science has become democratized. Data scientists today have most of them, or 46% of them, have less than 2 years of experience with data science, or have not been formally trained. So thank you for this nugget, Johnny. I appreciate it. It helped me tell the story. I appreciate that very much. So what are these strategies? Well, let's embrace what Gartner calls the citizen data scientist. Okay, who could be a data scientist? A data professional, an ETL developer, a dashboard developer, a report writer, a database engineer, Oracle developer. We have them by the hundreds of thousands in the IT workforce. Those are great data scientists because they understand data. Let's also kind of walk away from the notion that a data scientist is a unicorn, a purple unicorn that's got all of these skills, and really adopt the notion that data science is a team sport, right? I've listed some of the roles. A data scientist is supported by data analysts or data engineers, data stewards. And what I didn't get into this graphic was, and supported by systems engineers, and supported by subject matter experts, the people who know the mission. Together, that team is how we attack, how we build successful AI solutions. Making data analysts into data scientists. I have a slide with more details coming up on that, but the idea here is any of these people can be made more powerful with tools and techniques and services like those that you'll hear from Balaji will be talking about in a few minutes. Use these AI tools, use these cloud native services for both your data scientists and your data analysts and your developers and even your executives. They can all use these tools to build solutions. Then the last two couple thoughts on approach, right? Dive in with pilots. I like that, what I heard earlier today from the panel. Don't fail fast, but learn fast, right? if you build a pilot or a proof and you move on from there, you'll learn and converge much more quickly than if you approach it with a waterfall technique. Use agile methods. Do proofs, pilots, get your feet wet, get your people trained. And then the last idea is use all of your data, cast the wide net. If you own data and you're a data steward or you have a program that has data, make it available for others, because that diversity of data is what gives us the power of more successful and more wider solutions. Okay, good. All right. So I'm going to dive in just really quickly here and then then turn over the stage. I've lost track of my time. My timer dropped. So how do we engage the workforce? I've got 3 pillars here. The first one is to recognize, again, for the data scientists and the data analysts, right? The data scientists are the coders. They can write in Python. They can use tools like Python and R and Scala. Make sure they get those environments and those tools. And then for the clickers, we have these AI services like the AWS machine learning services, SageMaker. There's a whole host of other vendors that provide services so that you can click by connecting things, a data flow, right, to a machine learning algorithm, to training, to the testing, to evaluation, to deployment. So you don't have to write a line of code. You can just string together these primitives. There's a whole host of AI-assisted tools that you want to make available. Self-service tools for data visualization, data preparation, data analysis. Those help our data people understand the data so they can model it better and so they can build more powerful algorithms. Take advantage of the AI and ML services that are available in the cloud. Our cloud service providers, I'll be telling us a little more about this, have everything from facial recognition, speech recognition, machine translation, predictive engines, the ability to use time series forecasting. All of these services are available and are growing. So take advantage of cloud service providers and machine learning services that are available in the cloud. Data science platforms that help us get data from this raw state into a model that's deployed, and deep learning frameworks. You don't have to write a deep learning framework, you just have to be able to use one. You don't have to write a TensorFlow algorithm, or you can use Keras to help you build your models and deploy them. And then my last thought is on learning. So all these tools are available. People could start tomorrow. They can dig in and have some fun. There's great tutorials. There's great ways to get your hands dirty. But at the same time, you want to have some background, right? Some formal background. And academia is just now starting to put out data science degrees, specializations in AI and ML. I think, Brian, you took your son out to colleges last week, spring break, and your finding schools are now offering data science as a master's program. Terrific. Coursera, Andrew Ng, and all the other MOOCs offer great classes online. You can take those classes. Some are free, some are very inexpensive, and you can teach yourself. There's training offered free training offered across the board. AWS offers some training. You'll hear some more about that in a few minutes. And then certifications. We're here seeing big data certifications, cloud certifications in AI, cloud in ML, cloud in big data. Those are all ways to get a firm education behind these hands-on experiences. So, AI is here today. We have a shortage of workers. These methods will help us develop an AI workforce that's across the board, a whole range of capabilities from junior 2 years all the way through senior people using these tools and techniques. And with that, we can optimize, we can automate, and we can innovate across the federal mission space. And now, I'll turn the stage over to Balaji. Thank you.
Great. Thanks, Dave. Really excited to be here. Thanks for your time. My name is Balaji Iyer. I lead the public sector business development for machine learning and AI at AWS. One of the key topics that customers often engage at is the topic of AI. If you think about the benefits of AI, it's been commonly known that it's transformative. It can make a bottom-level business impact for your business and your line of work to make it your organization transformation, whatever your mission needs that may be. But the journey to getting there, it's usually a wandering process and a path of exploration rather than a desire to go solve a specific need. If you think about the latest articles from any magazine out there today or any research article coming from Gartner or IDC, there's a huge focus on the machine learning and AI capabilities, how we can transform your business. As a matter of fact, from a recent IDC article said 40% of the digital transformation initiatives are supported by AI this year alone. And 2021, the business value of the AI-driven initiatives are going to surpass over $50 billion. So we're at an inflection point where the hype cycle of this technology is actually transforming into a mission capabilities where we're seeing huge business impact for customers and also for mission owners. So I want to provide some insights on how we think about machine learning at Amazon, how we are using that in Amazon, and what capabilities are available as part of the platform today. So you go solve your problems, you're better equipped to know what capabilities are out there. So we've been doing machine learning at Amazon for over 20 years. Not a lot of people know this. If you think about any time you order an item in Amazon, there's a set of recommendations that driven by recommender systems, that's driven by machine learning. At the fulfillment center, we bought a company called Kiva Robotics over 6 years ago. And since that time, we built over 100,000 of these robotic devices. They are really optimizing the time for the picker and the sorter fulfillment center, and really energizing our ability to go deliver for our customers. So since that 6-year period, we built over 100,000 of these. At the same time, we hired over 300,000 more employees, and it allowed Amazon to be a $1 billion company. And all of this automation, all of this investments on machine learning and AI has really, we're the biggest beneficiaries today. We're working on a prototype for drone initiatives on what are the ways we can think about delivering a package to your front yard or backyard using a drone. And if you have used Alexa, it's constantly powered by machine learning and AI capabilities that are powered from the cloud. Amazon Go Store is our way to make shoplifting legal. It's a checkout-free store. You can walk into the store, pick any item from the aisle, walk right out, and we provide you a receipt. And these are only some of the examples of where we are using machine learning and AI today. And as part of the way we think about Amazon, machine learning in Amazon is we don't want to have a 12th floor that's where all the machine learning experts are. We power technologists and empower them with technologies, so everybody is empowered to use these capabilities. We have an applied science group that is not an independent business unit. They are constantly embedded with our AWS service teams that are building the product, so that we actually have a research project that has a driven customer initiative that has the output where all this research work that we're doing is actually impacting bottom line of the customers. So what is our mission at AWS? We want to make machine learning boring to a point where it is easy for everybody to be able to use. So the threshold, the barrier to entry for machine learning is pretty high right now. So our goal is to, every day, to lower the barrier so every one of us can build intelligent applications. So what are we trying to do? We are very customer obsessed. It's one of our leadership principles. 90% of our product roadmap is actually provided by feedback from our customers. So we listen to customers, we understand kind of what their needs are today and tomorrow, we go innovate on their behalf, and that's how all the products that you see today are actually from customers. And last year alone, we released over 200 new machine learning service and capabilities because our customers are asking us to build these capabilities, and we're innovating on their behalf. And the way we are thinking about the ecosystem for machine learning and AI is, in general, is we want to provide every tool in the toolbox. So we don't want to lock you in a specific vendor product or a specific type of framework. We want to provide all the tools from every available vendor so you have the right tool for the job. And on top of that, machine learning is usually the icing in the cake. We want to have a really secure environment. You want to have a deep analytics capability. You want to have the ability to store and compute. And all those available is in AWS. So that's why we are investing on this. That's also another reason why more machine learning is happening in AWS than anywhere else. So you see customers across every segment of the population, and every business, small and large, they are taking advantage of machine learning today. Having that said, it's still day one for a lot of customers. So this is how we're thinking about machine learning at AWS today, and here are some of the capabilities that are available for you to innovate. Let me break this down a little bit. we think about machine learning in the form of 3 layers of the stack. In the bottom layer of the stack, these are frameworks and infrastructures that we provide for customers. This is for expert practitioners. If you have a deep machine learning, deep learning background, usually they ask us capability to have all the frameworks available, be part of the platform, so they can go innovate. TensorFlow is probably one of the most commonly used, most popular frameworks. And as a matter of fact, 85% of the TensorFlow models that are running on the cloud are actually running on AWS. So we have first-party support for TensorFlow. A lot of times when you're trying to solve problems in recommender systems or image recognition or natural language processing, TensorFlow is not always the best fit for that. So a lot of times you're exploring PyTorch or Apache MXNet or other frameworks that might help solve the problem. So here we want to provide every tool in the tool chest. So in this case, we also have support for MXNet, PyTorch, and Gluon, and Keras. And in the middle layer of the stack, we abstract a lot of that away. It is built for developers and data scientists to accelerate their workflow, starting from building a model, testing and training and tuning the model, and also deploying your model. So we want to crank that chain as fast as you can. We want to provide you the tool set as part of our product called SageMaker. So the whole idea is to accelerate your machine learning workflow by providing a managed service on top of that. On the top layer of the stack, we abstract that even further. So you don't even have to create a machine learning model or train or tune or any of that. So we provide a single API where you can access very advanced capabilities for computer vision or for speech and language recognition and translation, and or building a forecasting system or a recommender system. So all those capabilities are available in your fingertips in a single call of an API, where we manage the models underneath, we train them, tune them, so you just pay as you go kind of model. At some point, our customers asked, why are you releasing so many services? What is your method of madness? So this is what we're trying to do. We are in the business, in the long term, focusing on solving some of the most toughest challenges that hold back success for machine learning for our customers. That's why you see the pace of innovation is just accelerating. So after working with a lot of our customers, there are 3 common themes that we heard consistently where they struggle the most. First, they want the flexibility of different frameworks. Doesn't matter who creates those frameworks. And they want to do that in a lower cost as they go scale. If you think about the cost, inference is probably the 90% of the cost for customers running machine learning workloads, so we want to reduce that cost even further. And there's a huge data challenges. Data is essentially the feeder for building a successful machine learning model. So good quality data is really important for good quality prediction. And we wanted to solve that problem as well. And the third thing we heard from customers is, why is it so hard? Can you make it even easier for us to use these capabilities? So we went to work. And so here are some of the things that we, additionally on top of our machine learning platform that we released at re:Invent last year in November in 2018. To help with the cost, we launched a service called, we launched a new instance type for P3. It's called P3DN. It's the fastest, most powerful GPU available in the cloud today. And as part of this, you can reduce the cost because your models are going to be trained faster, because you have a lot of compute capacity that you can throw at. And if you think about the TensorFlow, stock TensorFlow model, the vanilla TensorFlow, the utilization is only 65% of the resources. We forked the TensorFlow codebase and offered an AWS optimized TensorFlow that improves the resource utilization to 90%. Elastic Inference is a way to add GPU capacity to your existing EC2 instance. We also launched a new chip called AWS Inferentia to reduce the cost even further. For removing the barrier to entry for data, we launched SageMaker Ground Truth to reduce the cost for labeling and annotating. It's a fully managed labeling and annotating service where you can provide the data. We provide a managed training set and made it available for you. And also, you can integrate with other partners as well. We have a fully managed reinforcement learning for cases. There are 2 main paradigms for machine learning. There's supervised and unsupervised. For cases where you don't have any data, we're seeing a huge uptake on reinforcement learning usage. So we have a fully managed reinforcement learning environment as part of our SageMaker platform. To make it easy, we have a machine learning marketplace where you can actually lease a model or take a model that somebody has built from the marketplace and use it for your mission use case. We also have a SageMaker Neo product that we launched. It's basically a model compiler. So you want to build the models in the cloud, and you wanted to deploy it across your set of devices that may be running NVIDIA or ARM or Intel or Xilinx. Any of those, you can actually use that model compiler to go build it. And forecast, we've been doing forecast at Amazon for a long time, so we provide a managed forecasting service as part of this. So you can do forecasting. Recommender systems, we also been doing the recommender system as part of the Amazon business for a long time, so we took that model essentially and we're making it available to all customers using personalized. Textract is our OCR product where you can persist the rows and columns, and also if you're extracting data from digital documents, you can do that. Comprehend Medical is another way for accessing natural language processing as part of a managed service. So having all that said, where can you get started? So we launched something called as Amazon Machine Learning University, where this is a training course that we developed for internal Amazon engineers for the last 3 years, and it's available for everybody to use. As you could see, we have learning paths for different personas. If you're a developer, business decision maker, data scientist, data engineer, or you want to try one of the machine learning exams, you could try that as well. We also launched experimental device. It's called Deep Racer. If you're interested in reinforcement learning, it's a 1/18 size of a race car. You can do reinforcement models to make it run autonomous driving on a racetrack. And here's another one for computer vision. So these are cases where you don't have any use case. You want to go play with it and understand it so you can learn more. And Deep Lens is our option for building computer vision models. You can actually deploy and train the model and actually deploy it on the device to do object recognition, image identification, text extraction, and things like that. So you can learn more about all the things that I talked to you about and more at aws.ai. Thank you for your time.